Welcome to the Sociology and Criminology Research Methods Basics, Part 2 video. Now, the ultimate goal of sociology and criminology research is to generate knowledge either by building new, testable theory or through testing existing theory. What does that mean? Well, let me see if giving just a couple examples might help. Political sociologists are usually interested in understanding the causes and consequences of nation-state organization, action, inaction, use of power, things like that. For example, a political sociologist may use theories of collective action to discover the spark that ignites political upheaval that brings about lasting social change. Criminologists are particularly interested in the causes and consequences of crime. We may find new, interesting ways to test deterrence theory or rational choice theory to better understand why members of a specific population are choosing not to participate in crime at all. As a result of our test, we may find that the region where a population lives is more important than most other factors. Pretty interesting, right? I guess beginning in about the 4th or 5th grade, most of us learned about something called the scientific method. Usually we relate the scientific method to a physical or biological science fair type project, but the social sciences use the scientific method as well. After watching this video, you should feel comfortable demonstrating and explaining how the scientific method is used in sociology and criminological research, the keys to achieving the goals of our research, and the most common research designs, their benefits, and their limitations. So what exactly are the overarching goals of sociology and criminology research? Ultimately, we want our theories to be both testable and falsifiable. What good is a theory if it cannot be falsified? Our research subjects involve human beings, and as I'm sure you've noticed, our behaviors aren't always 100% predictable, so no social science can prove anything. Be wary, very wary, of any claim to prove with certainty anything involving human behavior and social constructs. When we conduct research, we hope that someone else can perform the exact same study and find the same conclusions. This is replication. And it's often why, as a student, you're bored to death by the tedious repetition and tiny, tiny details included in an academic journal article. We don't do that to drive you crazy. Instead, we do that because we want our research to tell a story, but more importantly to many of us, is that another scholar could read our paper and follow exactly what we have done. The next goal is generalizability. Ideally, we'd like our conclusions to apply to everyone and every situation similar to what our study focuses on. To meet the generalizability goal, it would be ideal to include every single individual, school, city, county, state, whatever the level of measurement is in our study. If we want to better understand health outcomes of a particular population, it'd be better to include as many people or all the records possible than to include just one city's worth. Why? Because if I only look at the health outcomes of, say, the recent immigrant population in one city, then my results can really only apply to that recent immigrant population in that city. Including an entire population, all of the recent immigrants, across all cities, isn't always feasible for a number of reasons. So the next best thing is to include a random, representative, large sample. Let's think back to our research question in the Part 1 video. If we're interested in understanding how middle schoolers listening to rap music predicts juvenile gang membership, we could find a way to study every single middle school aged child in the world. We could collect all middle school aged kids, separate them into 2 groups, put each group in a bubble so they aren't exposed to any outside influences that are different from one another, introduce just one rap music song to one bubble, and watch what happens. Or we can survey or observe every single middle school aged kid at least once before they start listening to gangster rap, and then for a period after they've started listening. Get real! All middle school age students? No. Social scientists often choose to narrow the population down. Maybe we decide middle schoolers in the United States, and then we decide to study a certain percentage of this population. If we truly use a large, randomly chosen group of students, our sample will be representative of the entire U.S. middle schooler population. Thank you, statistics, for the central limit theorem. Now, there are different ways we can sample. Snowball sampling means meeting one middle schooler and asking to speak to their middle school friend, and then asking that friend if you could speak to their middle school friend. With a research question like we have, this seems a little silly, but it's very useful if you're studying a population that is typically very tricky to meet. For example, drug dealers, or people who commit burglaries but haven't been caught yet. Maybe you're interested in learning more about human trafficking. Snowball sampling, in those cases, might make a lot more sense. We could use a convenience sample. A convenience sample is exactly what it sounds like, conducting a study using research subjects that are convenient, like going to your little sister's middle school and just talking to all the kids at her school. Or maybe, depending on your research question, you decide to conduct a study that uses only your college classmates as the study sample. We could take a systematic random sample. This would be choosing every third kid from a list of all middle schoolers in a specific district, city, or state. We could take a cluster sample and use a certain percentage of middle schoolers from each middle school in our district, our city, or our state. There are a number of ways to choose our sample. Choosing a sample depends on a few things: our research question, ethical considerations, the cost, and how much money we have, as well as the logistics: how, who, when, where, and for how long. Okay, so back to the scientific method. We start with a research question. We talked about this in Research Basics Part 1. Then we review relevant research to learn more about what other scholars and disciplines have found related to our question, concepts used, how they've been operationalized, limitations, theories used to guide the body of work. Ultimately, we're learning how our thoughts and our study will add something new. Next, we develop our hypotheses. We always have at least two hypotheses. H1 is our research hypothesis. Now, sticking with our rap and gang joining example, our research hypothesis is something like middle schoolers who listen to at least 40 hours of gangsta rap music per week are more likely to join a juvenile street gang than their peers. But there's another hypothesis. In social science research, when we have a predictive or a causal question, the null hypothesis is there, but it's not always stated in writing. The null hypothesis simply states that there is no relationship. So in our case, the null hypothesis is that there is no relationship between middle schoolers listening to gangster rap and gang joining. Now we have our research question. We know what other studies have found and how they've added to the field's knowledge. We have our hypothesis. So here, we can begin to design a study and systematically collect our data. Now, before we go too far down the gangster rap rabbit hole, let's review the different types of research questions commonly asked in social science research. Maybe we're interested in understanding how many teens smoke cigarettes regularly, or maybe what are the characteristics of teens who smoke cigarettes regularly. This is descriptive. We're trying to describe the characteristics or the population of teenage people who smoke cigarettes regularly. If we want to learn about a mechanism, in other words, what leads teens to start or stop smoking, we're asking essentially, why do teens smoke or stop smoking? Why is an exploratory question. Finally, when we're asking a causal or predictive research question, for example, how does the Real Cost anti-smoking campaign affect high schoolers' choices to smoke cigarettes? This is causal, predictive, maybe evaluative research question. So depending on the type of research question we ask, we have different commonly used research designs we can choose from. We could conduct an experimental, cross-sectional, panel, longitudinal, observational, documentary, or participatory research. Now, these aren't all mutually exclusive designs. We could decide that to really answer our question and maybe test our hypotheses, we should combine one or more of these designs. That's awesome. Just remember, you'll have to justify your choices. Now, an experimental study is the gold standard. In fact, the winner of experimental studies is the RCT, or randomized control trial. This one is like the study I mentioned earlier, placing middle schoolers in a bubble. Medicine often uses RCT designs. You've probably heard of them. The sample is divided into two groups. One is given the medicine that the scientists hope but aren't sure will have an effect. The other group is given a medicine that the scientists know won't have an effect. Neither group knows if the medicine they've been given is going to be effective in treating their ailment. But as awesome as this sounds, to answer questions in a pretty solid way, when conducting research on human behaviors, we have to keep ethics in mind. We can't give one group a treatment that we're pretty sure will work and deny the other group. We learned from Tuskegee just how nasty this idea can be. We must, as researchers, be 100% certain that we have no idea if our experimental condition will work. Another reason RCTs aren't always possible is because human behavior is not 100% predictable. Human beings are influenced by all sorts of things: their friends, their family, personal experiences, history, neighborhoods, and they can even be influenced by knowing that they're part of a study and they want to perform exactly as they think the researcher wants them to. With social science, research just isn't as simple as conducting experiments. Our subjects are people or groups of people, so sometimes we have to come up with pseudo-experiments in order to protect our subjects and still obtain reliable results. RCTs can also be very expensive, especially if we're interested in long-term outcomes. If you've ever had a chance to look at a medical RCT for a new drug, do it. You'll quickly see that often, due to costs, the sample size is quite small, and the amount of time included in the study is just as short as is required by the FDA to meet their minimums. Oh, speaking of time, a cross-sectional study is a snapshot at just one time point. Cross-sectional studies are great when you have a descriptive research question. If you want to know how many teens or the characteristics of teens who smoke regularly, conducting a survey in 2021 might do the trick. Depending on how we choose our sample and the information we ask about in our survey, we might be able to make generalizable conclusions. What we cannot do with a cross-sectional study is establish any causal relationships. There's that tricky chicken and egg question, which comes first? If we only have data at one point in time, there's no way of knowing which came first. This is an issue of what we call temporal order. So we can conduct a panel study, basically conduct two cross-sectional studies using the same survey. We'll have two time points, say 2 years or 10 years apart. This gives us an idea of which came first, but so much can happen over time that we still can't really make solid claims about causes. A longitudinal study gets the silver medal in social science research. Next to an RCT, this is as good as it gets. In a longitudinal study, we follow the same individuals over a very long period of time. Or maybe we're interested in social movements, so we study city or nation-state characteristics over time. As you can probably imagine, longitudinal studies are not only time-intensive, but they're expensive. And when we're studying human beings, we need a large enough group to follow over time so that we can make our findings generalizable. Human beings often move, change their minds, and don't want to talk to you every month or every year. They might even up and die on you. So longitudinal studies have some pretty tricky complications and limitations. Observational studies have a lot of possibilities. They can have any temporal structure. So they could be cross-sectional, panel, or longitudinal. And they help us learn about behaviors in the natural setting. For example, a social scientist might spend time sitting back and simply observing the population that they're interested in learning more about. Careful here, stalking, still a thing. A scientist may let people know who they are and what they're doing, spend time in a specific place or with a specific sample of groups to learn more about their customs, values, culture, subculture. Sometimes a scientist will ask probing questions, and they're always carefully documenting every detail. Stay aware, though, of a dirty, easy mistake to make. Scientists make mistakes all the time, and a common one in observational studies, don't get me wrong here, this mistake happens across all research designs, is something called sampling on the dependent variable. This mistake recently reared its head in a very public, nasty way in policing research, so it's worth mentioning. Sampling on the dependent variable means, essentially, not considering or including other possibilities in your research. For example, if you're interested in learning about middle schoolers' listening habits and gang joining, but you only observe or collect data on middle schoolers who listen to rap and who are gang members, you're missing all of those who are country music listening gangsters or rap listening never gang members. If you only include the group you want to focus on, you'll misinterpret and misreport what you learned. Okay, documentary research designs are, thanks to publicly available data and advanced technologies, very common. These designs use secondary data collected by someone else or some other institution, usually for a purpose that's different than what you have in mind. But they're the least expensive and less time-consuming than other research designs. With documentary research designs, you must be very aware of what the data can tell you. For example, the U.S. Census has a wealth of information on populations in the United States. There is a census every 10 years and other census surveys that occur more frequently. But these data tell us about populations. They're aggregate, like the percent of people living in a city who have a high school diploma and the percent of a population who are unemployed. We can learn from these data if cities with a higher percentage of unemployed residents have a lower percentage of those with a high school diploma. But we cannot learn if a single person who is unemployed, say only completed the 8th grade, is also unemployed. Finally, you could decide to use a participatory design. Participatory research is often called action research. Qualitative, like observational studies, the participatory design is one in which a scientist intentionally participates in the behaviors while observing. The goal is usually to understand how to create or mobilize change, or deepen knowledge on an inner working of a social group. Sounds so cool, right? But be careful. The researcher-subject boundary easily becomes blurred, and you risk going native, which, if you're conducting participatory research as a planted inmate of a prison, can not only alter your ability to remain objective, but you may soon begin to see your identity shift from scientist to inmate, altering your behaviors altogether and putting yourself at serious risk without even realizing what has happened. Next steps of the scientific method are to empirically analyze your data. Then note the limitations of your work, how your work may apply to policy, programs, how it adds to our body of knowledge, and what questions you still have or the questions that arose as you were conducting your study. You will always have questions by the time you finish one study, which brings us back to step 1 of the scientific method. And so the circle continues. In our Research Methods Basics Part 2 video, we learned how sociology and criminology uses the scientific method. We've explored key requirements for meeting the goals of social science research, and we have experienced a broad overview of the most common research methods, the elements of research methods, their benefits and limitations. Let's take what we've learned on a quick test drive. So our research question is, how does listening to rap music predict gang joining? We know the concepts in this question are listening, rap music, and gang joining. Let's define our concepts. Gang joining, like we mentioned in the Part 1 video, is the self-report of a person who states they have joined a gang in the past year. Rap music is music sold in the United States under the genre gangster rap. Listening is intentionally hearing rap music 1 hour or more per day. Our null hypothesis is that there is no relationship between listening to gangster rap and gang joining. Our research hypothesis is, if adolescents listen to rap music, then they join gangs. We conduct our literature review and determine that we'll use social learning and social control theories to guide which extraneous or control variables we'll include in our work and how we'll operationalize these variables. We know that our dependent variable is gang joining because we hypothesize that it depends on listening to gangster rap music, our independent variable. Based on our question and hypotheses, we're conducting a predictive or causal study. We might choose to use a survey, an interview, or maybe conduct a mixed method study and combine surveys with follow-up interviews. We'll definitely want to think through all ethical considerations. What's left? What questions will we ask and how will we ask them? Will we choose a sample or a population? Now, based on the stuff we've learned in this video, it's likely that you might want to write a research proposal to conduct a cross-sectional mixed method study. You'll probably suggest taking a sample of, say, all 13-year-olds from every mid-school in our city. You'll obtain informed consent from parents, because remember, 13-year-olds cannot consent. You'll let the kids feel like they are consenting by providing them with something similar. Informed assent. You'll design a survey that is theoretically based and you'll distribute it to your sample. Since you're an overachiever, you'll perform some follow-up, semi-structured interviews to get some thoughts on the mechanisms of gang joining or gang avoiding. Finally, you'll note your limitations, suggest future research possibilities, and note any implications for policy or programs. Most likely, you won't be arguing to ban all gangster rap music from middle school ears, but maybe. Thanks for watching.